Hello everyone, welcome back to AI Academy. Today we will continue our course on data mining. In last video, we covered the basics of data mining and data warehousing. In this video we will cover topics like application in data warehousing, its architecture, and so on. Data warehouses are critical for modern businesses, especially for business executives who need to organize, analyze, and leverage data for effective decision-making. These systems store and manage large volumes of historical data, making it possible to generate valuable insights that support strategic decisions. It also plays a pivotal role in a plan-execute-assess cycle, forming the backbone of a closed-loop feedback system in enterprise management. Let's explore some important applications of data warehouses, focusing on how they are benefit to the different industry one by one. Let's start with one of the important industry that we use in our day-to-day life, that is banking industry. In this industry, data warehouses are indispensable tools that enable banks to manage, analyze, and use vast amounts of data effectively. Here are some key applications. First is risk management and policy reversal. In this, banks use data warehouses to monitor and manage risks. By analyzing historical data, banks can identify potential risks, such as loan defaults or fraudulent transactions, and develop strategies to mitigate them. This also allows for more informed policy reversals when necessary, ensuring compliance with regulatory requirements. Next is consumer data and market trends analysis. Data warehouses help banks analyze consumer data, enabling them to identify trends in customer behavior. This information is crucial for understanding market dynamics and tailoring products and services to meet consumer needs. Government regulations and financial decision-making. Compliance with government regulations is a significant challenge in the banking industry. Data warehouses assist in ensuring that banks meet regulatory requirements by providing accurate and timely data. Moreover, they aid in financial decision-making by offering insights into financial performance and trends. While talking about resource management, banks use data warehouses to optimize the use of available resources. This can include everything from staffing levels to the allocation of financial assets, ensuring that resources are used efficiently and effectively. Next is market research and product analysis. Data warehouses support market research by providing a centralized repository of market data. Banks can analyze this data to assess the performance of different products and identify opportunities for new offerings. Exchange rates and marketing program development. Some banks use data warehouses to monitor and analyze exchange rates, which is vital for developing strategies related to foreign exchange services. Additionally, data warehouses support the development of marketing programs by analyzing customer behavior and market trends. Finally, customer relationship management. By analyzing transactions, spending patterns, and the types of merchants that cardholders interact with, banks can create personalized offers and deals. This enhances customer satisfaction and loyalty by providing tailored services that meet the specific needs and preferences of individual customers. While talking about finance industry. In the finance industry, data warehouses are used in a manner similar to the banking industry but with a broader focus on financial trends and customer behavior. Key applications includes: first is spending pattern analysis. Data warehouses enable financial institutions to analyze the spending patterns of their customers. By understanding these patterns, they can offer personalized financial products and services, such as tailored investment options or customized credit card offers. This not only improves customer satisfaction but also maximizes the profits earned by clients. Next is trend evaluation. Financial institutions use data warehouses to evaluate trends in the financial markets. This can include analyzing stock market data, currency exchange rates, or interest rate trends. Such analyses are critical for making informed investment decisions and managing financial portfolios. Profit maximization. This helps by leveraging the insights gained from data warehouses, financial institutions can identify opportunities to maximize profits. This might involve optimizing pricing strategies, identifying new market opportunities, or improving operational efficiencies. Let's discuss how retail industry works. In the retail industry, data warehouses are essential for managing and analyzing vast amounts of data related to customer behavior, inventory, sales, and marketing. Let's see how data warehouses are used in detail. First is analyzing customer purchasing behavior, which includes data warehouses collect and store data on customer purchases over time. By analyzing this data, retailers can identify trends and patterns in customer buying behavior. This includes understanding which products are popular, how often customers make purchases, and any seasonal trends. Personalized recommendations, which means with insights from purchasing behavior, retailers can create personalized recommendations for customers. For instance, if a customer frequently buys certain types of products, the system can suggest similar or complementary items. Next is monitoring inventory levels, which includes real-time inventory tracking, in which data warehouses help retailers keep track of their inventory in real time. This means they can monitor stock levels, understand which items are selling quickly, and identify which products are understocked or overstocked. By analyzing inventory data, retailers can optimize their stock levels to reduce excess inventory and avoid stockouts. This helps in managing inventory more efficiently and reduces carrying costs. Analyzing sales trends, which includes tracking sales performance. Retailers use data warehouses to track sales performance over different periods. They can analyze sales data by various factors, such as time, location, and product category, to identify trends and patterns. Forecasting sales. Historical sales data helps retailers forecast future sales trends. This forecasting can inform inventory decisions, staffing needs, and promotional strategies. Understanding customer buying habits, which includes segmenting customers. Retailers use data warehouses to segment their customer base into different groups based on buying habits, preferences, and demographics. This segmentation allows for targeted marketing and personalized offers. Improving customer experience. By understanding customer preferences and behaviors, retailers can tailor their products and services to better meet customer needs, enhancing the overall shopping experience. Optimizing the supply chain. Efficient stock replenishment. Data warehouses provide insights into inventory turnover rates and supply chain performance. Retailers can use this information to streamline their supply chain operations, ensuring that products are restocked in a timely manner. Retailers can analyze data related to supplier performance, including delivery times and order accuracy. This helps in managing supplier relationships and improving the efficiency of the supply chain. Finally, we have planning marketing campaigns and promotions. In this, data warehouses enable retailers to plan and execute targeted marketing campaigns based on customer data. Retailers can create promotions and advertisements tailored to specific customer segments or based on purchasing history. After launching marketing campaigns, retailers use data warehouses to analyze their effectiveness. They can track metrics such as customer engagement, sales increases, and return on investment to evaluate the success of their campaigns. In case of healthcare industry. In the healthcare industry, data warehouses are vital for managing and analyzing large volumes of patient and operational data. Here is how data warehouses are utilized in detail. Storing patient data. Data warehouses store a wide range of patient information, including personal details, medical histories, treatment records, and outcomes. This central repository ensures that all relevant data is available in one place, making it easier for healthcare providers to access and review patient information. By consolidating historical patient data, healthcare providers can track changes in a patient's health over time. This historical perspective is crucial for understanding long-term health trends and making informed treatment decisions. Next is improving patient care. With access to comprehensive patient records, healthcare providers can make more informed decisions about treatment plans. Data warehouses allow for a holistic view of a patient's health, including past treatments and responses, which aids in tailoring care to individual needs. Data warehouses enable the analysis of patient data to identify patterns and predict potential health issues. This helps in customizing treatment plans and preventive measures based on each patient's unique health profile. Managing resources more effectively. Data warehouses provide insights into the usage of medical resources, such as hospital beds, equipment, and staff. By analyzing this data, healthcare facilities can optimize resource allocation to ensure that they are used efficiently and effectively. Operational efficiency, such as analyzing data related to patient flow, appointment scheduling, and staff productivity, helps healthcare organizations streamline their operations and reduce wait times and operational costs. Complying with regulatory requirements. Data warehouses facilitate compliance with various healthcare regulations and standards. They store data required for reporting purposes, such as patient outcomes, treatment protocols, and financial records, ensuring that healthcare providers meet regulatory requirements. Data warehouses help maintain the security and confidentiality of patient data. They implement safeguards to protect sensitive information and ensure compliance with data protection regulations, such as Health Insurance Portability and Accountability Act. Predicting patient needs. Data mining techniques applied to data warehouses help predict patient needs by analyzing patterns in historical data. For example, predictive models can forecast which patients are at risk of developing certain conditions, allowing for early intervention. By using predictive analytics, healthcare providers can proactively address potential health issues, leading to improved patient outcomes and reduced hospital readmissions. Ensuring appropriate care. Data warehouses enable the integration of data from various sources, such as primary care providers, specialists, and labs. This integration ensures that all aspects of a patient's care are coordinated, reducing the risk of fragmented or duplicated services. Outcome tracking, which includes analyzing treatment outcomes stored in data warehouses, helps healthcare providers evaluate the effectiveness of different treatments and interventions. This information is used to refine care practices and improve the quality of care provided. Our next topic is telecommunications industry. They rely heavily on data warehouses to manage and analyze extensive volumes of data related to call records, customer behavior, and network performance. Here is how data warehouses are used in the telecommunications industry. We will start with analyzing call data records, which includes detailed call information, in which data warehouses store comprehensive call data records, including details such as call duration, timestamps, call origin and destination, and call type. This data is crucial for understanding usage patterns and managing telecommunications services effectively. Usage analysis, in which by analyzing call data records, telecom companies can assess call volumes, peak usage times, and network load. This analysis helps in optimizing network capacity and improving service delivery. Next is understanding customer usage patterns, which includes behavior insights, where data warehouses aggregate data on customer usage patterns, including call frequency, data consumption, and service preferences. This information helps telecom companies understand customer behavior and tailor their offerings to meet specific needs. Personalized services, which means by analyzing customer usage data, telecom companies can develop personalized service plans and promotions that align with individual usage patterns and preferences. Then comes optimizing network performance. Network monitoring, in which data warehouses provide insights into network performance metrics, such as bandwidth usage, signal strength, and connection quality. This data is essential for monitoring network health and identifying areas that need improvement. Infrastructure planning. In this, the analyzing network performance data helps telecom companies plan for infrastructure upgrades and expansions. It allows them to address potential bottlenecks and ensure that the network can handle current and future demands. In improving customer service includes service quality analysis, which by analyzes data from customer interactions and feedback, telecom companies can assess the quality of their customer service. This analysis helps identify areas where service can be improved and informs training and support strategies. Issue resolution, in which data warehouses help track and manage customer complaints and service requests. By analyzing this data, telecom companies can streamline their support processes and resolve issues more efficiently. Developing new services, which includes market research, which means data warehouses provides valuable insights into customer needs and market trends. Telecom companies use this information to develop and launch new services and features that meet evolving customer demands. Product innovation. This analyzes usage patterns and feedback, helps telecom companies identify opportunities for innovation and create new products or enhancements to existing services. Detecting fraud. Data mining techniques applied to data warehouses help telecom companies identify unusual patterns and anomalies in call data. This can indicate fraudulent activities, such as SIM card cloning or unauthorized use of services. By detecting fraud early, telecom companies can take preventive measures to protect their network and customer accounts, reducing financial losses and maintaining service integrity. Improving service quality, which includes pattern recognition, which means data mining helps in recognizing communication patterns and identifying areas where service quality can be improved. For example, analyzing call drop rates and connection failures helps in addressing issues that affect customer satisfaction. Performance optimization. In these, insights gained from data analysis help in optimizing network performance, enhancing service reliability, and ensuring a consistent quality of service for customers. When we talk about consumer goods industry, predicting shopping trends. Companies use data warehouses to forecast what products consumers will buy. They track inventory levels to ensure products are available when needed, which is called inventory management. Advertisement research. Data helps in understanding which ads work best and where to spend marketing dollars. Sales and production analysis. Companies can compare sales data with production data to optimize processes and improve efficiency. Communication with partners and clients. Data warehouses help streamline how information is shared between business partners and clients. While we talk about manufacturing industry, manufacturers use data warehouses to track production data, supply chain performance, and quality control metrics. This helps them improve production efficiency, reduce costs, and ensure product quality. Let's see how insurance industry works. Insurance companies rely on data warehouses to analyze claims data, customer demographics, and risk factors. This information is essential for setting premiums, managing risk, and detecting fraudulent claims. Let's discuss about government sector. In the government sector, data warehouses are essential tools for managing and analyzing vast amounts of data related to public services, taxation, and population demographics. Here's a detailed look at how data warehouses are utilized across various government functions. Let's check one by one. Starting with storing and analyzing data related to public services, which includes comprehensive data collection. Government agencies use data warehouses to store a wide range of data related to public services, such as healthcare, education, transportation, and social services. This includes information on service usage, provider performance, and service outcomes. Service quality assessment. By analyzing this data, agencies can assess the effectiveness and quality of public services. For example, they can track wait times in healthcare facilities, monitor school performance metrics, and evaluate the efficiency of public transportation systems. Improving service delivery. Data analysis helps in identifying gaps in service provision and areas where improvements are needed. This enables agencies to enhance service delivery and address public needs more effectively. Managing taxation data, which includes tax records management. Data warehouses store comprehensive tax records, including individual and corporate tax returns, payment histories, and compliance data. This central repository ensures that all tax-related information is readily accessible for analysis and reporting. By analyzing tax data, government agencies can identify trends in tax payments, detect potential compliance issues, and improve the efficiency of tax collection processes. This helps in maximizing revenue and reducing tax evasion. Insights from tax data support the development of tax policies and reforms. Agencies can analyze the impact of tax policies on different demographics and economic sectors to create more effective and equitable tax regulations. Analyzing population demographics. Data warehouses handle large volumes of census and demographic data, including information on population size, age distribution, gender, and geographic location. This data is crucial for understanding population dynamics and planning public services. By analyzing demographic trends, government agencies can predict future population needs and allocate resources accordingly. This includes planning for infrastructure, healthcare, and education based on population growth and shifts. Understanding demographic data allows agencies to design and implement targeted programs that address the needs of specific population groups, such as senior citizens, youth, or low-income families. Then comes supporting policy development. Evidence-based policy-making data warehouses provide the necessary evidence and insights for developing and evaluating public policies. Agencies can analyze data related to public health, crime rates, and economic indicators to inform policy decisions. By analyzing historical data and evaluating the outcomes of implemented policies, government agencies can assess their effectiveness and make data-driven adjustments to improve policy outcomes. Next is resource allocation. When we talk about budget planning, data warehouses support the allocation of government resources by providing insights into spending patterns and resource utilization. This helps in creating more accurate budgets and ensuring that resources are allocated to areas with the greatest need. Enhancing public service delivery comes next. Data analysis helps in optimizing the delivery of public services by identifying inefficiencies and bottlenecks. For example, analyzing data on service requests and response times can help improve the efficiency of emergency services. Data warehouses enable government agencies to better understand citizen needs and preferences. This information can be used to enhance public engagement and tailor services to meet the expectations of the community. Let's discuss the education sector, which plays a very important in our life. Educational institutions utilize data warehouses to effectively manage and analyze a broad range of data related to student performance, enrollment trends, and financial information. Here's a detailed look at how data warehouses are used in the education sector. First is tracking student performance. Data warehouses store detailed records of student performance, including grades, test scores, attendance, and participation in extracurricular activities. This centralized data allows educators to have a holistic view of each student's academic journey. By analyzing student performance data, educational institutions can identify trends and patterns in academic achievement. This helps in understanding which students are excelling and which may need additional support. With insights from performance data, educators can implement targeted interventions and personalized learning plans to address individual student needs and improve overall educational outcomes. Next is managing enrollment trends. Data warehouses keep track of enrollment data, including student applications, admissions, and retention rates. This information helps institutions understand enrollment patterns and trends over time. Analyzing historical enrollment data allows institutions to forecast future enrollment trends. This helps in planning for capacity, staffing needs, and resource allocation to accommodate changes in student numbers. Enrollment data supports strategic planning by providing insights into student demographics, program popularity, and geographic distribution. This information is used to make informed decisions about program offerings and marketing strategies. Analyzing financial data. Data warehouses store financial information related to budgeting, expenditures, and revenue sources. Institutions use this data to manage budgets, track spending, and ensure financial stability. Analyzing financial data helps in allocating resources efficiently across various departments and programs. It enables institutions to make data-driven decisions about investments and cost management. Data warehouses facilitate accurate financial reporting and compliance with regulatory requirements. Institutions can generate detailed financial reports for internal use and external audits. Improving educational outcomes. Insights from performance and enrollment data inform curriculum development and program design. Institutions can identify areas where students are struggling and adjust the curriculum to address these gaps. Data warehouses provide the data needed to evaluate the effectiveness of educational programs and initiatives. Institutions can assess program outcomes and make adjustments to improve quality and relevance. Managing resources. Data warehouses help in managing staffing and facility resources by providing data on student numbers, class sizes, and facility usage. This ensures that resources are used efficiently and helps in planning for future needs. Analyzing data related to operations, such as class schedules and student services, helps in streamlining administrative processes and improving overall efficiency. Making informed decisions. Data warehouses provide a comprehensive view of institutional data, enabling administrators and educators to make informed decisions based on empirical evidence rather than intuition. By leveraging data insights, institutions can develop and implement strategic initiatives aimed at improving student outcomes, enhancing operational efficiency, and achieving institutional goals. When we talk about energy sector. In the energy sector, data warehouses are used to analyze data related to energy production, consumption, and pricing. This information is vital for optimizing energy generation, managing demand, and setting prices. Travel and hospitality industry comes next. Travel and hospitality companies use data warehouses to analyze customer preferences, booking trends, and operational performance. This helps them improve customer service, optimize pricing strategies, and increase bookings. Hotels, restaurants, car rentals, and resorts use data warehouses to plan and run advertising campaigns based on customer feedback and travel habits. Data warehouses are used to track shipment data, route efficiency, and fuel consumption. This helps companies optimize their operations, reduce costs, and improve delivery times. Insurance. Understanding customer behavior. Data warehouses help insurance companies analyze customer behavior and develop targeted offers and promotions. Finally comes service sector. In the service industry, data warehouses help manage financial data mining applications. Understanding customer behavior. Companies use data mining on warehouse data to analyze customer preferences, pricing, and sales impact. Retail example. Retailers can use this data to create products and promotions that meet specific customer needs. Financial data analysis. In finance, data mining helps with loan predictions, customer classification, and detecting financial crimes. Discussing different topic completes our discussion on application in data warehousing. Now we will continue our discussion with another interesting topic, that is data warehouse architecture. A data warehouse is a system that collects and combines data from different sources. It helps in creating reports, answering specific questions, and making decisions. Some data warehouses use data from a limited number of sources, while others, especially those used by large companies, use data from a wide range of both internal and external sources. It is non-volatile. It records all data changes as new entries without erasing its previous state. Since building a data warehouse depends on the specific needs of the business, let's explore the common layers that are found in every data warehouse structure. All data warehouse architecture includes the following layers: data source layer, data staging layer, data storage layer, data presentation layer. Figure of data warehouse architecture. In the given figure you can see the different layers like data source layer, staging area, data warehousing, which is the storage layer, and last the presentation layer. Let's go through each layer one by one. First we will start with data source layer. It is the foundation of a data warehouse architecture, where the original data from various sources is stored in a relational database. This layer collects data from both internal and external sources, which can include different types of information. Here are some examples of data sources. Operational data includes essential business information like product data, inventory records, marketing data, and HR, that is, human resources, data. These are the everyday operations that keep the business running. Social media data. This type of data comes from online interactions, such as website visits, the popularity of certain content, and how often users complete actions on a web page, like filling out a form or making a purchase. Third-party data, in which the data is collected from outside organizations, like demographic information, survey results, or census data. These external sources can provide additional context or insights. While many data warehouses focus on structured data, which is organized and easy to analyze, it's important to also think about unstructured data. Unstructured data includes things like voice recordings, scanned documents, and text that don't fit neatly into tables. Even though this data is less organized, it holds valuable insights and should be considered when developing a data warehouse. Next is, the data staging layer is an essential part of the data warehouse architecture, positioned between the data sources and the data warehouse itself. This layer is where data is first brought in from various internal and external sources. Here's how it works. In data extraction, the data comes from different sources, and these sources often use various formats. To handle this, the data extraction process employs different technologies and tools to pull the needed data from each source. Data quality checks is the next step, in which after the data is extracted, it undergoes high-level quality checks to ensure it is accurate and clean. This step is crucial because poor quality data can lead to incorrect conclusions and bad business decisions. The staging layer contains the following components. First is, landing database and staging area. The landing database is where the raw data, straight from the sources, is temporarily stored. The staging area is where the data undergoes quality checks and is cleaned up before it is moved to the data warehouse. This cleaning and organizing step is vital, as poor data quality at this stage can lead to flawed information being stored in the data warehouse. Next is, data integration tool. Extract, transform, and load tools are the data integration tools. These are specialized tools used in the data staging layer. They handle the entire process of extracting data from the source systems, transforming it into a suitable format, and loading it into the data warehouse. The transformation step may include cleaning the data, converting it to a standard format, and combining data from multiple sources. The data staging layer ensures that only clean, well-prepared data is loaded into the data warehouse, which is critical for accurate reporting and effective decision-making. The data storage layer is a crucial part of the data warehouse architecture. This is where the cleaned and organized data from the staging layer is stored in a single, central location. Let's see in detail. In central repository, after data has been cleaned and processed in the staging area, it is stored in the data storage layer. It is the main place where all the data resides, making it easy to access and analyze. Next is, types of data storage, in which, depending on the specific needs of the business and the design of the data warehouse, the data storage layer can take different forms. Data warehouse, which is a large, centralized repository where all the data from various sources is stored. It is designed to support complex queries and analysis across the entire organization. A data mart is a smaller, more focused version of a data warehouse. It is often created for specific departments or business units within a company, such as sales, finance, or marketing. It contains a subset of the data stored in the main data warehouse, tailored to the needs of a particular group. Operational data store is used to store current or near real-time operational data. Unlike a traditional data warehouse, which is optimized for long-term storage and analysis, it is designed for quick access to up-to-date information. It is often used to support day-to-day operations and short-term decision-making. The data storage layer is essential because it provides a well-organized, easily accessible repository of data that can be used for reporting, analysis, and decision-making across the organization. By centralizing the data, businesses can ensure consistency, accuracy, and completeness in the information they use. The data presentation layer is the part of the data warehouse architecture where users can access and interact with the cleaned and organized data. This layer is crucial because it allows users to gain insights, analyze information, and make informed decisions. Let's see how it works. User interaction, in which the presentation layer is designed for end users, allowing them to work with the data easily. Users can query the data to gain insights into products, services, or any other area of interest. They can also analyze the data to explore different business scenarios or conduct studies, whether automated or ad hoc, that is, on the spot, as needed. While talking about tools for analysis and reporting. Online analytical processing tools that allow users to explore large amounts of data quickly. They enable complex queries and help users view data from different perspectives. Reporting tools with graphical user interface, where these tools offer a user-friendly interface, making it easier for users to build queries, perform analyses, and design reports. It simplifies the process, so even those without deep technical knowledge can interact with the data effectively. Planning for flexibility and longevity. When designing a data warehouse, it is essential to ensure that the presentation layer can handle both structured and unstructured data. This means it should be flexible enough to work with well-organized data like numbers and tables, as well as more complex data types like text documents or multimedia files. Additionally, the presentation layer should be cross-functional, meaning it should support different departments or business functions within the organization. In long-term foundation, the presentation layer should be built to provide a strong, long-term foundation for data provision and decision support. This ensures that as the business grows and evolves, the data warehouse can continue to support its needs, providing reliable information for decision-making over time. The data presentation layer is vital for turning raw data into actionable insights, making it a key component of any data warehouse architecture. Let's discuss on new topic, Business Analytics Framework. A business analyst uses information from data warehouses to measure how well the business is performing and make important changes to stay competitive in the market. Here are some benefits of using a data warehouse. Improved productivity is one of the benefits of a data warehouse, which can gather information quickly and efficiently, which helps improve business productivity. Consistent customer view that provides a consistent view of customers and products, which aids in better customer relationship management. Cost reduction is one of the main benefits of data warehouse. By tracking trends and patterns over time in a consistent and reliable way, a data warehouse helps reduce costs. To design an effective data warehouse, it is important to understand and analyze the business's needs and create a business analysis framework. People have different perspectives on how a data warehouse should be structured, and these views include: top-down view, in which the perspective focuses on selecting the relevant information needed for a data warehouse. Data source view, that shows the information being captured, stored, and managed by the operational systems. In data warehouse view, the perspective includes the fact tables and dimension tables, representing the information stored inside the data warehouse. Business query view, this is the view of the data from the end user's perspective, focusing on how they interact with the data. Three-tier architecture. A data warehouse typically follows three-tier architecture, consisting of the following layers. First is bottom tier, which is the data warehouse database server, where the data is stored in a relational database system. Back-end tools and utilities are used to feed data into this layer. These tools handle the tasks of extracting, cleaning, loading, and refreshing the data. Next is middle tier. In this layer contains the online analytical processing server, which can be implemented in two ways. Relational OLAP, which is the extended version of a relational database management system that maps operations on multidimensional data to standard relational operations. Multidimensional OLAP. This model directly implements multidimensional data and operations, allowing for faster and more complex data analysis. Finally, top tier, which is the front-end client layer, where users interact with the data through applications or tools that allow them to query, analyze, and generate reports. The following diagram shows the three-tier architecture of data warehouse. Let's see the detailed explanation of data warehouse models. When it comes to the architecture of a data warehouse, there are three main models to consider: the virtual warehouse, data mart, and enterprise warehouse. Each model serves different purposes and is tailored to meet specific business needs. First, we will start with virtual warehouse. It is essentially a view over an operational data warehouse. It is a simpler and more flexible option compared to the other models. Instead of storing data physically in the warehouse, it pulls data directly from operational databases whenever a query is made. Its advantages are: they are easier and faster to set up since it leverages existing databases. Requires less storage space as it doesn't need to duplicate data. When we talk about considerations, it relies heavily on the performance and capacity of the existing operational database servers, so it requires excess capacity to function effectively. Next is data mart. It is a smaller, more focused version of a data warehouse. It contains a subset of the organization-wide data, designed to serve the specific needs of a particular department or group within the organization. Let's take an example of a marketing data mart that might focus on customer behavior, sales figures, and product details. When we talk about implementation, data marts are typically implemented on Windows, Unix, or Linux-based servers, which are usually less expensive and quicker to set up than those used for full-scale data warehouses. They can be set up in a matter of weeks, making them a quick solution for departmental needs. Let's check its characteristics. It is smaller than an enterprise warehouse. Data marts are usually tailored to departmental needs. Since they are customized for specific departments, they can be more flexible and easier to manage. While they can be set up quickly, poor planning or design that doesn't take the entire organization into account can lead to complexity over time. Now it's time to discuss about enterprise warehouse. An enterprise warehouse is the most comprehensive data warehouse model. It collects and integrates data from all across the organization, covering all subjects and areas of the business. Now let's see how it works. It consolidates data from various operational systems and external sources, providing a centralized, organization-wide data repository. The volume of data stored can range from gigabytes to terabytes or even beyond, depending on the size of the organization and its data needs. Its benefits are: enterprise-wide integration that offers a unified view of all organizational data, making it easier to perform comprehensive analysis and reporting. Scalability is another benefit that can handle very large volumes of data, making it suitable for large enterprises with extensive data needs. Let's discuss about Load Manager, which is an essential component in data warehouses. It is a crucial part of the data warehouse architecture. It is responsible for managing the process of extracting data from various sources and loading it into the warehouse. Its functions are: data extraction, that is, it pulls data from different source systems. It acts as a temporary storage. The extracted data is loaded into a temporary storage area where it can be processed. They performs basic transformations on the data, ensuring that it is in a format that can be easily loaded into the data warehouse. The complexity of the load manager can vary depending on the specific requirements of the data warehouse. It plays a vital role in ensuring that data is efficiently and accurately moved into the warehouse for analysis. In the diagram, on the left side is Load Manager. The Load Manager section lists different tools and processes that help in managing the data load into the warehouse. Controlling process. This part controls the overall data loading process. It makes sure everything runs smoothly and in the right order. Stored procedures. These are pre-written SQL commands that are used to process and manipulate data efficiently during the load. Copy management tool that handles copying data from different sources into the data warehouse. Fast loader, which is a tool designed to load data quickly into the warehouse, especially when dealing with large amounts of data. Its goal is to load data into the data warehouse as quickly as possible, minimizing the total load window, that is, the time it takes to load data. Right side is data structures. On the right side, you have two key structures inside the warehouse. Temporary data store, which like a waiting area where data is temporarily held before being moved to its final destination in the warehouse. Warehouse structure, that is the main area where data is stored after it has been processed and is ready for use in analysis and reporting. Extracting data from source systems. Extracting data is the first crucial step in building a data warehouse. This process involves pulling data from operational databases or external information providers to be used in the data warehouse. Here is a detailed look at how this works. Data extraction from operational databases and external sources. Data is typically extracted from various sources like operational databases, example, sales, finance, and inventory systems, or external data providers, example, market research data, third-party APIs. Gateways are application programs that facilitate the extraction of data. They enable communication between the client program and the database server. Examples are common gateways include Open Database Connectivity and Java Database Connectivity. These technologies allow SQL queries to be generated and executed on the server, enabling data extraction. When we talk about fast load, challenges it faces are impact of transformations, that is data transformations, converting data into the desired format or structure, can slow down the loading process. To optimize speed, it's often more efficient to load the raw data into the relational database before applying any transformations. Gateway limitations. Gateway technologies like ODBC and JDBC may not perform well when dealing with large volumes of data, making them less suitable for high-speed data loading. Let's discuss about simple transformation. Before performing complex checks, some simple transformations might be necessary during the loading process. These transformations help prepare the data for further processing. Steps in simple transformation are: first, remove unnecessary data. Strip out any columns from the data that are not needed in the warehouse. This reduces the amount of data to be processed and stored. Convert data types is the next step. It ensures that all data values are converted to the correct data types required by the warehouse. For example, a date field might need to be converted from a text format to a standard date format. Let's take an example. When loading sales transaction data, like electronic point of sale, or EPOS, data, into the warehouse, the system might remove columns that are irrelevant for analysis. Convert currency values into a standardized format or change text-based dates into a more usable date format. By handling these simple transformations during the loading phase, the system ensures that the data is clean and ready for more complex processing once it's in the warehouse. This approach helps streamline the overall process, making data loading more efficient and effective. Let's discuss about Warehouse Manager. First, we will start with roles and architecture. A warehouse manager plays a critical role in the overall management and operation of a data warehouse. This component is responsible for overseeing the processes involved in maintaining the data warehouse, ensuring data integrity, and managing data flows. The complexity and size of a warehouse manager can vary depending on the specific needs and architecture of the data warehouse solution being implemented. Warehouse Manager Overview. It is typically composed of various tools and scripts, including third-party system software, custom C programs, and shell scripts. These components work together to control the flow of data, manage backups, ensure recovery, and execute various tasks required to keep the data warehouse running smoothly. Let's see about Warehouse Manager Architecture. The architecture of a warehouse manager includes several key components, each serving a specific function in the data warehouse management process. First is controlling process. It is the core of the warehouse manager. It oversees and coordinates the various tasks that need to be executed within the data warehouse. This process manages the scheduling and execution of jobs, ensures that data flows correctly from source systems to the warehouse, and monitors the overall health and performance of the data warehouse environment. Next is stored procedures or C programs with SQL. Stored procedures or C programs embedded with SQL are used to perform specific tasks within the data warehouse. Its usage is: first is stored procedures. These is precompiled SQL code that can be executed to perform repetitive tasks like data validation, transformation, and aggregation. Custom C programs with embedded SQL can be used for more complex operations that require higher performance or specific functionality not easily achieved with SQL alone. Then is backup/recovery tool. This tool is essential for ensuring that the data warehouse can be restored to a consistent state in case of a failure, data corruption, or other issues. Its responsibilities are: regular backups are scheduled and managed to ensure that data is securely stored and can be recovered if necessary. The tool also provides the ability to restore data from backups, ensuring that the warehouse can quickly recover from unexpected disruptions. SQL scripts. SQL scripts are used to automate various tasks within the data warehouse. Its usage are: data manipulation is the first use. SQL scripts can be used to manipulate data, including updating, deleting, or inserting records based on specific criteria. Next is maintenance tasks. Scripts are often employed for routine maintenance tasks, such as reorganizing indexes, cleaning up temporary tables, or refreshing materialized views. The warehouse manager is a crucial component of the data warehouse architecture, responsible for managing the various processes that ensure the warehouse operates efficiently and reliably. Through a combination of controlling processes, stored procedures, custom programs, backup/recovery tools, and SQL scripts, the warehouse manager ensures that data is consistently and accurately processed, maintained, and protected within the data warehouse environment. On the left side is labeled as Warehouse Manager. Controlling process, which is like the brain of the data warehouse system. It oversees and controls the flow of data, ensuring everything runs smoothly, such as when and how data gets processed. Stored procedures or C with SQL. These are predefined sets of instructions or programs, written in SQL or C, that handle specific tasks in the data warehouse, like moving or transforming data. Think of them as automated scripts that perform repetitive tasks. Backup/recovery tool, which is a safety feature that ensures data is backed up, saved, and can be restored in case something goes wrong. It's like a safety net for the data warehouse. SQL scripts that are written commands in SQL that perform various operations, like extracting or updating data. They are like instructions the system follows to manage the data. On the right side, the diagram represents the data flow or structure. Temporary data store. This is where data is temporarily held during processing. It's like a waiting room for data before it moves to its final destination. Snowflake schema, which is a type of data structure or model used in data warehouses. It organizes data in a way that makes it easier to query and analyze. It's called snowflake because the structure resembles a snowflake, with several levels of data tables connected in a hierarchical way. Summary tables. These are tables that store summarized data, often used for quick reporting. Instead of going through large amounts of raw data, the system can use these summary tables to get faster results. Let's discuss about, what does a warehouse manager do? The warehouse manager plays a crucial role in ensuring that a data warehouse runs smoothly and efficiently. Here's a breakdown of the key operations they perform. First is, data consistency and integrity checks. The warehouse manager ensures that the data within the warehouse is consistent and follows the necessary rules for data integrity. This means checking that all data entries are accurate and those relationships between different sets of data make sense. Next is, creating indexes and views. To make data retrieval faster and more efficient, the warehouse manager creates indexes, business views, and partition views. Indexes help speed up searches, while views provide users with a simplified way to look at the data without having to interact with the raw data itself. Handling data aggregations comes next. The warehouse manager generates new aggregations, which are summarized forms of data, and updates existing ones. This helps in quickly answering complex queries that involve large amounts of data. The manager also performs normalizations, a process that organizes data to reduce redundancy. Data transformation and merging. Once the data is collected from various sources, the warehouse manager transforms it into a usable format and merges it into the main data warehouse. This ensures that all the data is available in one place and in a consistent format. Backup and archiving. To prevent data loss, the warehouse manager regularly backs up the data stored in the warehouse. Additionally, they archive data that is no longer needed for day-to-day operations but might be useful for historical analysis. Optimizing query performance. The warehouse manager analyzes query profiles to decide if new indexes or aggregations are needed. This optimization ensures that queries run as efficiently as possible, saving time and resources. Next point of discussion is about what does a query manager do. The query manager is like a traffic director for data queries, ensuring that user requests are processed quickly and accurately. Here is what a query manager does. Directing queries. When a user submits a query, the query manager directs it to the most appropriate tables within the data warehouse. This helps speed up the query process and ensures that users get the information they need quickly. Scheduling queries. The query manager is responsible for scheduling when queries should be run. This helps in managing system resources efficiently, especially when there are multiple queries or heavy data processing tasks. Query manager architecture. The architecture of a query manager includes several components. Query redirection. Using tools like C programs or RDBMS, Relational Database Management System, the query manager redirects queries to the right tables. Stored procedures. These are pre-written SQL scripts that the query manager can use to handle repetitive tasks or complex queries quickly. Query management tools. These tools help the query manager oversee and optimize the query process, ensuring that everything runs smoothly. Query scheduling. The query manager uses third-party software to schedule queries, making sure that they are executed at the right time without overloading the system. Detailed information in a data warehouse. Detailed information is not usually kept online. Instead, it's summarized to a higher level of detail and then stored on tape for long-term storage. However, in a data warehouse, detailed information is stored in a structure called the star flake schema. This detailed information is loaded into the warehouse to complement the summarized data, giving a complete picture when needed. The following diagram shows a pictorial impression of where detailed information is stored and how it is used. Summary information in a data warehouse consists of pre-calculated summaries or aggregations of data. These summaries are created by the warehouse manager and are considered temporary because they need to be updated frequently to match changing query needs. Key points about summary information. It helps speed up common queries. It increases operational costs. It needs to be updated every time new data is added to the warehouse. It doesn't always require backup because it can be recreated from the detailed data. A reference structure in software architecture is like a blueprint or template that provides guidance on how to design systems within a specific domain or area. It acts as a starting point, offering a proven way to organize and structure software systems. This structure includes a set of predefined components, layers, and patterns that help ensure consistency, efficiency, and scalability in the software development process. There are two common types of data warehouse architectures. First is a single data warehouse. This type of architecture has just one large data warehouse that serves as the central hub for all data in the organization. On top of this central data warehouse, there is a single data mart that contains the summarized and organized data needed for specific reporting or analysis tasks. This setup is simpler and works well for organizations where all the data can be managed and accessed from one place. Next is multi-mart data warehouse. In this architecture, instead of having just one data mart, there are multiple data marts built on top of the central data warehouse. This approach is more common in large organizations where it doesn't make sense to put all the data into a single data mart. Instead, different data marts are created for different purposes. For example, one data mart might be dedicated to international financial reporting, another for production analytics, and another for supply chain optimization. This setup allows for better organization and more efficient data processing tailored to specific business needs. Let's discuss about how many layers are there and for which purpose it is used. When it comes to layers in data warehouse architecture, each layer has a specific purpose. The layers are not just randomly included, they are carefully chosen by the data warehouse architect. Every layer is there for a reason, serving a particular function within the overall system. Let's start with staging layer. The staging layer in a data warehouse is like a temporary holding area where data is brought in from various source systems before being processed further. The main goal of this layer is to quickly and easily transfer data from the source systems into the data warehouse without putting too much strain on those source systems. Here is a breakdown of the staging layer's purpose and design principles. Understanding the staging layer in data warehouse architecture. It is an essential component of data warehouse architecture. It acts as a temporary storage area where raw data from various source systems is collected before further processing and loading into the main data warehouse. The purpose of this layer is to enable efficient data extraction and minimize the impact on source systems during the data loading process. Here is a detailed explanation of the staging layer, along with a diagram to help visualize the process. First, let's discuss about its purpose. First is quick data transfer, which is one of the important purposes. This layer facilitates fast data transfer from source systems to the data warehouse. This is crucial to avoid overloading the source systems, especially if they are critical to daily business operations. Next is temporary data storage. Data in this layer is stored temporarily. Once the data has been processed and loaded into the main data warehouse, it can be deleted from the staging area. This prevents unnecessary storage consumption. Then comes minimal processing in data, which is usually kept in its raw form. No transformations, aggregations, or data quality checks are performed at this stage. The main focus is to replicate the source data as quickly and accurately as possible. Delta extraction comes next, in which whenever possible, only the new or modified data, that is, delta, is extracted from the source systems. This reduces the volume of data transferred and minimizes the impact on the source systems. And finally, source system isolation, in which each source system has its own dedicated staging area, ensuring that data from different sources is kept separate. This helps manage workloads more effectively and prevents data from becoming tangled or mixed up. Now let's discuss one more important topic, that is design principles of the staging layer. First is 1:1 copy of source system, which contains an exact replica of the data from the source systems, with the same table structures, naming conventions, and data types. Next is transformations or aggregations, in which the data is stored as is, without any changes or calculations. The layer is purely for data transfer, not for data processing. Separate staging areas for each source comes next, in which each source system is given its own dedicated staging area, either as separate tables, schemas, or even databases, depending on the complexity of the architecture. Let's talk about why to use a staging layer. This layer helps reduce the load on important source systems, like an ERP system, example, SAP ERP, that is critical for daily business operations. By minimizing the impact on these systems, we can ensure they continue to run smoothly while still extracting the needed data. Also, delta extraction is often used here, meaning only new or changed data is pulled from the source system. This reduces the amount of data that needs to be moved and processed, making the whole system more efficient. Let's discuss about SSIS loading pattern. When loading data into the staging layer using SSIS, that is, SQL Server Integration Services, the process is straightforward. We connect to the source system using an adapter that works best for that specific system, example, OLDB source. Extract the data. Add some basic audit information, like when the data was loaded. Store the data in the staging table. The simplicity of this process is intentional, making it easy and quick to get data into the staging layer. The focus here is purely on efficient data extraction without additional complexity. Next is archive layer in data warehouse architecture. This layer acts like the life insurance for our data warehouse. Its primary job is to maintain a complete history of all our data. This means that every single change to our data is tracked and stored, even if it is not immediately needed for analysis. In a typical data warehouse, only about 10% of the data's history is crucial for business analysis. Tracking every single change directly in the core data warehouse would be very expensive and resource-intensive. So, instead of storing 100% of the history in the CDW, which might not be necessary, this layer keeps a full backup. This gives us the flexibility to access any part of our data history if we ever need it in the future, without cluttering the CDW with unnecessary data. The layer ensures that we don't lose important information, even if it isn't being used right away. By storing everything in the archive, we keep our options open for future analysis, without overloading your main data warehouse. Let's discuss about its purpose. Understanding the purpose of the archive layer in a data warehouse starts with grasping the concept of data history. In a data warehouse, there are two main types of data tracking. First is fact data changes. This is the simpler form of data tracking. Since fact data is linked to specific points in time, changes are automatically recorded. For example, sales transactions are fact data that naturally have timestamps, so their history is tracked easily. Next is master data changes. This is more complex and is known as tracking slowly changing dimensions. Here, changes in attributes like a customer's phone number or address need to be tracked over time. Unlike fact data, these changes aren't always linked to a specific event, making them more challenging to track. When we suggest not tracking the full history within the main data warehouse, we are referring to not recording every single change that happens immediately. Only about 10% of historical changes in dimension attributes, like addresses, are ever used by business users for analysis. So, why should we burden the data warehouse with tracking the other 90% of changes that no one uses? Often, the reason given is, we don't know what will be needed in the future. But is it worth paying the price for storing all that unnecessary data? The cost isn't just storage space, it also includes the processing overhead, such as handling complex joins in our data warehouse. These joins are resource-intensive and can slow down your system significantly. To solve this, we keep a full history of both fact and master data in the archive layer. This way, if there is ever a need to create a new slowly changing dimension table in the core data warehouse, we have all the historical data readily available. The archive acts as a safeguard, allowing us to create detailed historical records when needed, without overloading our primary data warehouse. In short, the layer stores everything, giving us flexibility for future needs while keeping our core data warehouse streamlined and efficient. Now, next topic is archive design principles. Let's discuss in detail and key principles it follows. This layer in a data warehouse plays a crucial role in preserving the entire history of data, ensuring that we have a reliable backup even if we don't track all changes in the core data warehouse. It is designed to be a faithful copy of the staging area, following specific principles to ensure consistency and efficiency. Here's a detailed breakdown of how the archive layer works. Let's discuss about key principles of the archive layer. First is 1:1 copy of the staging area. The archive is essentially a mirror image of the staging area. Every piece of data that enters the staging area is copied exactly into the archive, ensuring no changes or modifications are made. This 1:1 copy ensures that the archive serves as a complete backup. Next is consistent naming conventions and data types. To maintain uniformity, the archive uses the same naming conventions and data types as the staging area. This makes it easier to trace data back to its origin and ensures that the structure remains consistent across different layers. Then comes no transformations or aggregations, in which the data remains untouched. They don't perform any transformations, like calculations or data adjustments, or aggregations, such as summing values. The goal is to keep the data in its raw, original form, just as it arrived from the source systems. Next is no quality checks. Since the archive is simply a backup, it skips any data quality checks. The assumption is that any necessary checks have already been done in the staging area. One archive per staging area is next, in which each staging area has its own dedicated archive. This separation helps manage workloads and ensures that data from different sources is kept organized and isolated. Then comes use of compression and partitioning. To manage the storage size of the archive effectively, it is recommended to apply compression and partitioning. Compression reduces the amount of space the data takes up, while partitioning organizes the data into segments, making it easier to manage and retrieve specific extracts when needed. Finally, delta detection logic, when necessary. If our reference systems can only provide full data extracts, instead of just the changes, we will need to implement delta detection logic. This means comparing the new data with what is already in the archive and only storing the differences. Without this logic, our archive could grow rapidly, leading to inefficiencies. It ensures that only the necessary data changes are archived, optimizing storage and performance. Let's discuss again a simple and straightforward approach. The core data warehouse, that is, CDW, layer plays a central role in data warehouse architecture, primarily designed for business analysis and serving as a foundation for effective data processing. Let's break down the key points to understand its purpose and function in simple terms. The core data layer. The core data warehouse is where all the data from various sources across the organization is collected and stored. It aims to represent the entire enterprise at the most detailed level possible. This means it holds the raw, granular data that hasn't yet been aggregated or simplified. Next is supporting business analysis. Since the core data warehouse is used for business analysis, it organizes data in modules, typically following a star schema design. This is a popular data modeling technique where a central fact table, holding quantitative data, is linked to surrounding dimension tables, that is, holding descriptive attributes. The star schema makes it easier for analysts to efficiently. Quick ETL process. A key function of the core data warehouse is to support fast ETL, that is, extract, transform, load, operations. It refers to the process of extracting data from source systems, transforming it into a usable format, and loading it into the warehouse. Since this layer is critical for ETL, it is optimized to handle large volumes of data quickly and efficiently. Let's check why is quick ETL important. As business needs evolve, data models need to adapt. If our data model is complex and slow, it will drag down the entire ETL process, leading to delays in data availability. It ensures that data is loaded into the warehouse without unnecessary bottlenecks, enabling timely analysis. Let's see how to balance ETL and reporting. As business requirements get more complex, the demands on the data model also increase. We might need to optimize the data model for reporting by adding aggregations, that is, summing up data, indexes, to speed up searches, and other enhancements. The challenge it faces. Optimizing the CDW for both ETL and reporting can be tricky. What works best for one may not work well for the other. For instance, making a model faster for reporting could slow down the ETL process and vice versa. This is why careful design and balance are needed in this layer to ensure both ETL and reporting can run smoothly. Let's learn about data marts versus centralized data warehouse. Use cases. The following use cases highlight some examples of when to use each approach to data warehousing. Data marts are specialized subsets of a data warehouse that focus on specific business areas or departments. They allow organizations to store and analyze data related to a particular function, making data retrieval and reporting faster and more efficient. Here are some common use cases for data marts. First is marketing analysis and reporting. Marketing departments often deal with data specific to campaigns, customer behavior, and sales trends. This data is usually relevant only within the marketing unit and doesn't require a comprehensive view of the entire organization. By using a marketing data mart, the team can focus on their specific data needs without being overwhelmed by unrelated data from other departments. It enables quick access to relevant data, streamlining tasks like campaign performance analysis, customer segmentation, and sales reporting. Since the data mart is designed specifically for marketing purposes, it allows for more efficient querying and reporting. Next is financial analysis and reporting. Financial analysts need precise and detailed financial data to carry out tasks like budgeting, forecasting, and financial reporting. A finance data mart provides a tailored environment that houses all necessary financial data, making it easier to analyze without interference from unrelated data sets. With a finance data mart, financial analysts can quickly generate reports, conduct variance analysis, and monitor financial performance. The focused nature of the data mart ensures that all necessary data is readily available, improving the speed and accuracy of financial decision-making. Then comes why data marts are valuable. Data marts provide a specialized data environment tailored to the needs of specific business units. By isolating data relevant to a particular function, they reduce complexity, improve query performance, and enhance the overall efficiency of reporting and analysis. This targeted approach allows departments like marketing and finance to focus on what matters most to them, without being bogged down by the vast amount of data in the entire data warehouse. Then comes to centralized data warehouse use cases. It serves as a unified repository where data from various departments across an organization is consolidated. This allows for comprehensive analysis and decision-making, as all relevant data is stored in one place. Below are some detailed use cases where a centralized data warehouse proves invaluable. Supporting business expansion. When a company is considering expansion, whether it is opening new locations, launching new products, or entering new markets, it needs to make informed decisions based on a wide array of data. This data comes from multiple departments such as sales, marketing, IT, customer service, and supply chain management. A CDW aggregates data from all these sources, enabling the company to analyze everything in one place. For example, sales data can be combined with marketing performance, IT infrastructure data, and customer loyalty metrics to paint a full picture of how the expansion might impact the organization. By consolidating data, the company can identify trends, forecast demand, optimize resources, and minimize risks associated with expansion. This leads to more informed decision-making and a higher likelihood of successful growth. Next is profitability analysis in an insurance company. Insurance companies deal with various factors that impact profitability, such as claims processing, sales performance, customer demographics, and investment returns. To understand overall profitability, it is crucial to combine data from these different areas. A centralized data warehouses enables the insurance company to bring together data from its claims department, sales team, customer profiles, and investment portfolios. By centralizing this information, the company can perform detailed profitability analysis, ensuring that all contributing factors are considered. With a centralized data warehouses, the insurance company can generate comprehensive reports that provide insights into how different aspects of the business are affecting profitability. This allows for better strategic planning, more accurate pricing models, and improved customer segmentation. Ultimately, it helps the company make data-driven decisions that enhance profitability and operational efficiency. Let's discuss why centralized data warehouses are essential. It offers a powerful solution for organizations that need to combine data from multiple sources to make informed decisions. By centralizing data, companies can ensure consistency, accuracy, and accessibility, enabling cross-functional analysis and strategic decision-making. Whether it is a company planning for expansion or an insurance firm evaluating profitability, a centralized data warehouses provides the necessary infrastructure to bring together all relevant data, ensuring that no critical information is overlooked. Data mart versus data warehouse, understanding the differences. When it comes to managing and analyzing data in an organization, two key components often come into play: data marts and data warehouses. While they may seem similar, they serve different purposes and are designed for different scopes of data analysis. Let's explore the differences between them in detail. Let's start with what is a data mart. It is essentially a smaller, more focused subset of a data warehouse. It is designed to cater to a specific business line or department within an organization, such as sales, marketing, or finance. They are typically tailored to meet the unique needs of a particular department. For example, a sales data mart might store data related to sales transactions, customer interactions, and revenue, allowing the sales team to perform targeted analysis and reporting without needing to access the broader data warehouse. It often contains summarized or aggregated data, making it easier for business users to access and analyze information quickly. This is especially useful for departments that require fast insights without diving into raw, detailed data. Then comes what is a data warehouse. It is a large, centralized repository that consolidates data from various sources within an organization. It serves as the main hub for storing all kinds of data, including transactional, operational, and historical data. Unlike a data mart, which focuses on a specific business line, a data warehouse covers the entire organization. It integrates data from different departments, systems, and sources, providing a comprehensive view of the business. This makes it an invaluable resource for enterprise-wide analysis and decision-making. They store vast amounts of detailed and historical data, allowing for in-depth analysis over time. This data can be used for advanced analytics, reporting, data mining, and other strategic business processes. Let's see the key differences between data mart and data warehouse. While discussing scope, data mart has a narrow scope, focusing on a specific department or business unit. It is designed to meet the needs of a particular group within the organization. At the same time, data warehouses have broad scope, encompassing data from across the entire organization. It serves as a centralized data source for all departments and business units. In case of data volume, data mart typically contains a smaller volume of data, as it focuses on specific departmental needs and often includes summarized data. Whereas data warehouse handles a much larger volume of data, as it integrates and stores information from various sources across the organization. Similarly, while speaking about complexity, data mart has fewer complexes, with a more straightforward design and a narrower focus on specific business processes or reporting needs. At the same time, data warehouse has more complex, as it needs to integrate data from diverse sources, support various business processes, and accommodate different types of analysis. Data mart has generally faster for query performance, as it is optimized for specific tasks and contains less data, and data warehouse may have slower query performance compared to a data mart, due to the larger volume of data and the need to support more complex queries and analysis in case of speed and performance. And finally, while speaking about use cases, data mart has ideal for department-specific analysis and reporting, such as sales forecasting, marketing campaign analysis, or financial reporting. It allows departments to access the data they need without overwhelming them with unnecessary information. And data warehouse has best suited for enterprise-wide analysis, strategic decision-making, and long-term data storage. It provides a holistic view of the organization and supports more advanced analytics, such as trend analysis, predictive modeling, and data mining. How data marts and data warehouses complement each other. While data marts and data warehouses serve different purposes, they often work together within an organization's data architecture. A data warehouse acts as the central repository, storing all of the organization's data. Data marts, on the other hand, draw from this central repository to create focused datasets that meet the specific needs of individual departments. For example, a company's data warehouse might contain data from sales, marketing, finance, and operations. The sales team could then create a sales data mart, pulling relevant data from the data warehouse to perform their analysis and reporting. This approach allows departments to work independently while still leveraging the centralized data in the data warehouse. Let's see in details about the ETL process. The ETL process consists of 3 key steps. First is extract. This step involves gathering raw data from various source systems, such as databases, spreadsheets, or web applications. The goal is to pull the necessary data that will be used for analysis without overloading the source systems. Next is transform. Once the data is extracted, it is transformed into a format that meets the business's needs. This includes cleaning the data, applying business rules, filtering, aggregating, and converting it into the desired structure. The transformation step is crucial for ensuring that the data is accurate and consistent. And third is load. Finally, the transformed data is loaded into the data warehouse, where it is stored and made available for analysis. The data warehouse can then be used to generate reports, dashboards, and other business intelligence tools. Key features of the ETL process. Data summarization. ETL often summarizes data to reduce its size and improve performance for specific types of analysis. This helps in handling large datasets efficiently. Integration of data sources. When building an ETL infrastructure, it is essential to integrate data from multiple sources. This requires careful planning and testing to ensure that the data is transformed correctly. Automation. ETL processes are typically automated, which reduces manual effort and ensures that data is processed consistently and on time. Let's see the approaches to building an ETL process. There are different ways to build an ETL process. Below are 2 common methods. Building an ETL pipeline with batch processing. Batch processing. In this method, data is collected, processed, and transferred in batches from source databases to the data warehouse. Batch processing is effective for handling large volumes of data and can be scheduled to run at specific times, example, nightly. ETL tools. Building an ETL pipeline from scratch can be challenging, especially for enterprises. Tools like Stitch, Blendo, or Apache NiFi can simplify the process by automating many of the steps involved in data extraction, transformation, and loading. Reference data. It is important to define reference data, which specifies the allowable values in your datasets. For instance, in a country data field, you might list valid country codes. Building a pipeline without ETL using an automated cloud-based data warehouse. Cloud-based solutions. In this approach, modern cloud-based data warehouses, like Snowflake, BigQuery, or Redshift, can eliminate the need for traditional ETL by providing built-in tools for data integration and transformation. These platforms often support real-time data ingestion and processing, making them a viable alternative to the traditional ETL process. Direct data loading. Instead of extracting and transforming data before loading, cloud data warehouses allow you to load raw data directly and perform transformations as needed. This approach can be faster and more flexible, especially for organizations with rapidly changing data needs. Building an ETL pipeline with batch processing. Creating an ETL, extract, transform, load, pipeline with batch processing might seem challenging, especially if we are starting from scratch. However, using tools like Stitch or Blendo can simplify the process by automating many tasks. Here is a straightforward guide to building an ETL pipeline with batch processing. Reference data. First, define a set of acceptable values our data can have. For instance, if we have a country field, create a list of valid country codes that are allowed in our data. Extract from data sources. The success of the ETL process largely depends on correctly extracting data. Usually, we will be working with multiple data sources, each with its own structure and format. These could include relational databases, non-relational databases, XML, JSON, or CSV files. The goal is to convert this varied data into a uniform format for easier processing. Data validation. This step ensures that the data we have extracted is correct and meets the expected criteria. For example, if we are working with financial data from the past year, the date fields should only include dates within that time frame. If the data doesn't meet these criteria, it gets rejected. We will need to regularly review and address any rejected records to either fix the source data or adjust the extraction process for future batches. Transform data. In this phase, we clean up any unnecessary or incorrect data, apply business rules, and check data integrity to ensure nothing has been corrupted or lost. We may also need to create aggregates, such as summarizing invoice amounts into daily or monthly totals. This step often requires creating and testing a series of rules or using tools that perform the necessary transformations on the extracted data. Building a data pipeline without ETL using an automated cloud-based data warehouse. In recent years, cloud-based data warehouse technologies have made it easier to manage and analyze data without the need for a traditional ETL extract, transform, load process. One example of this is Panoply, a cloud-based automated data warehouse that simplifies the data management process by automating much of the work. Here is how it works. End-to-end data management. Panoply offers an all-in-one solution that handles everything from data extraction to transformation and optimization. It uses advanced technologies like machine learning and natural language processing, NLP, to automatically adjust the data to fit our analytics needs. Pre-integrated data sources. Panoply comes with built-in connections to a wide range of data sources, including analytics platforms, business intelligence, BI, tools, databases, social media, and advertising platforms. This makes it easy to bring in data from various places without needing to manually set up connections. Simple data import. To get started, we just select your data sources from a list, enter the necessary credentials, and define how you want the data organized. Then, we click Collect, and Panoply takes care of the rest. It will automatically pull in the data for us. Automatic data processing. Once the data is imported, Panoply handles everything from data structuring to data cleaning. This means you don't have to worry about setting up complex ETL processes or writing custom code to prepare your data for analysis. Let's continue our discussion on data warehouse architecture. It is built on a relational database management system that acts as the main storage space for informational data. It keeps operational data and processes separate from the data warehouse activities. This central repository is supported by several important components that help make the system work well, stay manageable, and be easily accessed by both the systems that send data to the warehouse and the tools used by end users for queries and analysis. Usually, the data that goes into the warehouse comes from operational applications. Once the data enters the warehouse, it is cleaned and transformed into a consistent format. The transformation process includes tasks like converting data, summarizing it, filtering out unnecessary details, and condensing it. Since the data warehouse stores historical data, it must be able to handle large amounts of data and different data formats over time. Our next topic of discussion is data warehouse database. The central database in a data warehouse is the foundation of the entire data warehousing system. This database is almost always built using relational database management system technology. However, traditional RDBMS products are mainly designed for handling transactional data, which can limit their performance in data warehouses. It have specific needs, like handling very large amounts of data, running ad hoc queries, and allowing flexible user views, such as creating summaries, joining multiple tables, and drilling down into details. These needs have led to the development of different technologies for data warehouse databases. These methods include: first is parallel database designs for scalability, which involve different ways of managing memory and storage. There are three common models. Shared memory, where multiple processors share the same memory. Shared disk, where processors share disk storage but each has its own memory. Shared nothing, where each processor has its own memory and disk. These models can be used in different multiprocessor setups, like SMP, that is, symmetric multiprocessors, MPP, massively parallel processors, or clusters of processors. Next is speeding up traditional databases by using new types of indexes that avoid the need to scan entire relational tables, which makes data retrieval faster. Multidimensional databases, which use specialized database technology. Alternatively, a dimensional data model, designed for easy reporting and analysis, can also be implemented using a regular relational database management system that many are familiar with. MDDBs are specifically built to overcome the limitations of relational databases. They allow online analytical processing, which belongs to a group of tools used for data querying, reporting, analysis, and mining in data warehousing. Let's see in detail about sourcing, acquisition, cleanup, and transformation tools. A significant part of building a data warehouse involves gathering data from various operational systems and then preparing it for analysis. This process isn't as simple as just copying data over. The data needs to be cleaned up, transformed, and formatted in ways that make it usable for reporting and decision-making tools. These data sourcing, cleanup, transformation, and migration tools take on the following tasks. Extracting data from multiple operational systems. Cleaning up the data, which means removing irrelevant or incorrect data that could affect the analysis. Transforming the data into a format that is consistent, structured, and useful for the data warehouse. Migrating data, meaning they move it from its original system into the data warehouse in an efficient and organized manner. These tools handle many different tasks, such as conversions, in which there is change in data types or formats so they are compatible with the data warehouse. Summarizations, in which condensing detailed data into summaries that is easier to analyze. Key changes. Modifying the unique identifiers, keys, used in different systems so that they match up in the data warehouse. Structural changes. Adjusting the layout or organization of data to fit the design of the data warehouse. Condensations, reducing the size of the data sets by focusing only on the most relevant information. Let's see how do these tools work. These tools automatically generate programs and scripts that handle the data movement and transformations. These could include COBOL programs, for older systems. MVS Job Control Language, JCL, used on mainframe systems. Unix scripts, for Unix-based systems. SQL Data Definition Language, DDL, for defining database structures. In addition to processing the data, these tools also manage metadata, which is essentially data about the data itself. Metadata keeps track of things like where the data came from, how it was transformed, and how it should be used in the data warehouse. Key functions of these tools. Some of the main things these tools do include removing unwanted data. They filter out irrelevant or unnecessary data from the operational systems so that the data warehouse only contains useful information. Standardizing data names and definitions. Data from different systems often uses different names or definitions for the same things. These tools ensure that everything is consistent, using common names and definitions across all data. Handling missing data. If some data is missing in the source system, these tools establish default values to fill in the gaps. Adapting to changes in the source systems. If the structure of the source data changes, these tools are flexible enough to adjust and accommodate those changes without breaking the data flow. Challenges these tools face. While these tools are incredibly useful, they have to deal with some complex issues, including database heterogeneity. Every database management system, DBMS, is different. They use different data models, query languages, ways of storing and retrieving data, and methods for managing things like data integrity and recovery. Integrating data from multiple DBMSs can be a big challenge. Data heterogeneity. Even when databases are structured similarly, the actual data can vary widely. For example, homonyms in the same data name may mean different things in different systems. Synonyms in different data names may refer to the same thing across systems. Unit compatibility. One system might use US measurements, like inches, while another uses metric, like centimeters. Different attributes for the same entity, which means two systems might store different details for the same type of data. Example, one system tracks only a person's name, while another tracks their name, address, and phone number. Different ways of modeling the same fact. In this, different systems might represent the same information in entirely different ways, making it hard to combine them. Limitations of these tools. Although these tools are very powerful and can save a lot of time, they do have some limitations. Most of the available tools work well for simpler data extractions, where the data structure and format are relatively straightforward. However, for more complex data extraction processes, especially when dealing with highly customized or unusual data structures, these tools may fall short. In those cases, developers often need to create custom extraction routines to handle the more complicated requirements. While talking about metadata, it is data that describe other data. It's information that describes everything inside a data warehouse, helping people understand and works with the data more effectively. We can think of metadata as a guidebook that explains the details of what is inside the data warehouse, how it is organized, what it means, and how it can be used. Metadata is essential for building, maintaining, and managing the data warehouse, and it also helps users find and understand the data they need. Let's see about types of metadata. Metadata can be divided into two main types. First is technical metadata. This is the behind-the-scenes information that helps the people who design and maintain the data warehouse. It includes details like where the data came from, source systems, how the data was processed, transformations, how the data is structured in the warehouse, that is, tables, columns, keys, etc. Technical metadata is mostly used by data warehouse designers, administrators, and developers when they are building or managing the warehouse. Next is business metadata. This type of metadata is designed for business users who need to understand the data in simple, non-technical terms. It explains what the data represents, for example, what sales means in a specific report, how to interpret the data, where to find specific types of information in the data warehouse. Business metadata is meant to be easy for non-technical users to understand so they can get the information they need without diving into the technical details. Let's check, how does metadata help users? One of the most important roles of metadata is making it easier for users to interact with the data warehouse. With metadata, users can understand the content of the warehouse without needing technical knowledge. Find the data they are looking for more quickly and easily, thanks to the descriptions and explanations provided by the metadata. Challenges with metadata. While metadata is very useful, there are some challenges when it comes to working with it. One issue is that many data extraction tools, which help pull data from different systems into the warehouse, don't always have the best capabilities for gathering and managing metadata. These tools are still improving, and because of this, organizations often have to build their own metadata interfaces, that is, tools that let users access and understand metadata, which can mean extra work and sometimes duplicating efforts. Let's see how to managing metadata. To keep all this metadata organized and useful, there is something called a metadata repository. This is basically a central storage area where all the metadata is kept. Along with the repository, there is also software that helps manage the metadata. This metadata management software can do things like map the source data to the target database. It connects the original data, from operational systems, to where it needs to go in the warehouse. Generate code for data transformations. It helps create the code needed to transform data, like converting different formats or summarizing data. Control the movement of data. It manages the flow of data as it moves from the source systems into the data warehouse. Evolving user interactions with metadata. As users become more familiar with the data warehouse, their way of interacting with metadata and data can evolve. At first, they might do simple, manual analyses, like looking for patterns or trends. Over time, though, they might start using more advanced methods, such as software agents that automatically analyze the data based on certain conditions or thresholds set by the user. For example, a user could set a threshold that triggers an analysis when sales drop below a certain level. These thresholds and rules are also stored in the metadata repository, along with the information directory, which tells the software agents where to find the right data for analysis. Access tools in data warehousing. The main goal of a data warehouse is to provide useful information to business users so they can make better strategic decisions. These users interact with the data warehouse through front-end tools, which make it easier to access and analyze the data. There are four main types of these access tools. Query and reporting tools. Application development tools. Online analytical processing, OLAP, tools. Data mining tools. Let's discuss one by one. Query and reporting tools. These tools help users pull information from the data warehouse and present it in a meaningful way. There are two types of tools in this category. Reporting tools. These are used to generate reports. Production reporting tools are for generating regular, large-scale reports like paychecks or operational reports. Report writers are simple, inexpensive tools that business users can use on their desktops to create custom reports. Managed query tools. These tools make it easy for users to query the data without needing to know complex SQL or how the database is structured. They provide a simple, point-and-click interface that generates the necessary SQL queries behind the scenes. Let's discuss about application development tools. Sometimes, the built-in features of query and reporting tools are not enough to meet the unique needs of a business. In these cases, companies often turn to application development tools to build custom solutions. These development platforms, such as Power Builder, Visual Basic, and Forte, allow developers to create custom applications that work well with the data warehouse. They also integrate with popular OLAP tools and can access major database systems like Oracle, Sybase, and Informix. First is online analytical processing tools. They are designed for users who need to do more complex analysis. They are based on dimensional data models, which allow users to look at data from multiple angles, or dimensions, such as product performance, profitability, or the success of a marketing campaign. With OLAP, users can easily analyze data using multi-dimensional views, which helps them make more informed business decisions. Common uses of it include sales forecasting, capacity planning, and evaluating the effectiveness of a marketing campaign. It works best when the data is organized in a multidimensional model, which is a structure that supports this kind of analysis. Next is data mining tools. Data mining is all about discovering hidden patterns, trends, and relationships in large sets of data. It's a powerful way for businesses to uncover new insights and opportunities. Data mining tools use advanced techniques like artificial intelligence, statistics, and mathematics to analyze data. This helps businesses discover meaningful patterns, such as customer behavior trends or market opportunities that they would not have noticed just by looking at the raw data. Why are these tools important? In today's fast-paced business environment, the ability to use data effectively is a critical success factor. Each of these tools plays a role in helping businesses tap into their data, whether it's through simple reports, custom applications, in-depth analysis, or uncovering hidden trends. By using the right combination of tools, organizations can make more informed decisions and gain a competitive edge. What is a data mart? The idea of data marts has generated a lot of excitement in the data warehouse world, mainly because they seem like a faster and cheaper alternative to building a full data warehouse. However, different people understand data marts in different ways. At its core, a data mart is a smaller, focused data store that is part of a larger data warehouse. It's designed to handle a specific portion of the data, often tailored to a particular group of users or a specific business function. Think of it like a smaller, specialized version of the main data warehouse. Let's see how data marts work. A data mart typically focuses on a single subject area, like sales, marketing, or finance, and provides denormalized, summarized, or aggregated data for a dedicated group of users. In some cases, the data mart might be stored as part of the main data warehouse. But more often than not, it's a separate database on its own server, usually within a local network for a particular user group. Some data marts use relational OLAP technology to create a highly simplified, denormalized model of the data, like a star schema. This makes it easier for users to analyze the data and get insights. While talking about dependent versus independent data marts, there are two main types of data marts, dependent and independent. Dependent data marts are built directly from the main data warehouse, ensuring data consistency and integration. At the same time, independent data marts created separately from the main data warehouse, often using standalone sources. While talking about integration, dependent data mart highly integrated with the main data warehouse, providing a consistent version of the data across the organization. Whereas independent data mart poor integration with other systems, often leading to data inconsistencies across the organization, and it uses when a specific business unit or department needs a tailored solution, independent of the central data warehouse. But in case of dependent, it uses when consistent enterprise-wide data access is needed, with centralized control. In case of tools and technologies, dependent data marts can use different tools or technologies, but the data remains consistent since it originates from a single, integrated source, whereas in case of independent often uses different tools and technologies with varying assumptions about how data is consolidated, leading to potential discrepancies. Let's check why independent data marts can be risky. One big issue with independent data marts is that once one department builds its own data mart, other departments might follow suit, each creating their own. This can lead to a situation where we have multiple systems feeding multiple, non-integrated data marts, causing overlapping data, scheduling conflicts, and management issues. In other words, it turns a one-to-many data problem into a many-to-many mess. Instead of a streamlined data warehouse, you end up with disconnected data marts, where different parts of the organization use different sets of data, which may not always match up. This goes against the whole idea of data warehousing, which is about integrating data for a unified view. Data marts in practice. A data mart contains a subset of data that is valuable to a specific group or department in the organization. For example, a marketing data mart might include information on customers, products, and sales, while a finance data mart could focus on budgeting and expenses. Typically, data marts are implemented on low-cost servers running Windows or Unix/Linux. They can be developed fairly quickly, often in just a few weeks. However, if they are not well planned, they can become complicated and harder to manage over time, especially if they do not align with the organization's overall data strategy. Data marts are generally small and flexible, making them easier to customize for specific departments. They are often built from a departmental data warehouse and are designed to meet the specific needs of that department. Managing a data warehouse. Data warehouses can be huge, often 4 times the size of the operational databases they work with. Depending on how much historical data you need to store, they can even reach terabytes in size. Unlike operational databases, data warehouses aren't updated in real time. Instead, updates usually happen once a day, or more frequently if needed by the business. One of the helpful features of most data warehouse systems is that they can access multiple data sources from across the organization using gateways. This means you don't need to rewrite your applications to interpret different types of data. These systems can work in heterogeneous environments, meaning the databases might be on different platforms, requiring networking tools to connect them all. Let's see why managing a data warehouse is important. With all these moving parts, it is clear that managing a data warehouse is essential. Here are some key tasks involved in data warehouse administration. Security and priority management. Ensuring that only authorized users can access the data and setting priorities for different processes. Monitoring updates. Keeping an eye on updates coming from multiple data sources to ensure everything is running smoothly. Data quality checks. Verifying that the data entering the warehouse is accurate and clean. Managing and updating metadata, which means maintaining the data about metadata to help users understand what is in the warehouse. Auditing and reporting means tracking who is using the warehouse and what they are doing with the data, as well as reporting on its overall status. Purging data, that is removing outdated or unnecessary data to keep the system efficient. Replicating, subsetting, and distributing data, that ensure data is replicated, divided into smaller sets, and distributed where needed. Backup and recovery, that is regularly backing up the data warehouse and having a plan to recover it in case of any issues. Storage management, that manages the physical storage of the massive amount of data that the warehouse holds. Let's continue some more important topic, that is, data warehouse administration and management. First, we will start with size and complexity of data warehouses, that tends to be significantly larger than their associated operational databases, sometimes as much as 4 times larger. This is due to the volume of historical data stored for analysis, which can reach terabytes in size, depending on the organization's need to save and analyze historical information. The sheer size of a data warehouse adds to the complexity of managing it effectively. Update frequency comes next, in which, unlike operational databases, which are updated in real time, data warehouses do not require continuous synchronization with operational data. Instead, they are typically updated periodically, often once a day, depending on the application's needs. This means that data changes in the source systems may not immediately reflect in the data warehouse, allowing the warehouse to be optimized for read-heavy operations, which is crucial for reporting and analysis. Let's talk about the key areas of data warehouse management. First, we will start with security and priority management. Since data warehouses often contain sensitive and business-critical data, security is paramount. This involves setting up user access controls, ensuring that only authorized personnel can access specific types of data, and protecting the data from external threats. In addition, priority management is necessary to ensure that critical business queries are given precedence over less important ones, especially during peak usage times. Next is monitoring updates from multiple sources. Data warehouses consolidate data from multiple sources. It is crucial to have a system that monitors these updates. This includes ensuring that data is loaded correctly, resolving any discrepancies between source systems and the warehouse, and handling potential data conflicts. Data quality checks comes next. Data accuracy is vital for effective business decision-making. Ensuring the quality of the data that flows into the data warehouse is essential. This involves running various checks to validate data integrity, consistency, and accuracy during the ETL process. Managing and updating metadata. It provides critical information on how data is structured, where it comes from, and how it should be used. Managing metadata helps in understanding the data lineage and provides context to users accessing the warehouse. Keeping metadata up to date is crucial for smooth data retrieval and interpretation. Auditing and reporting data warehouse usage and status is also one of the key areas of data warehouse management. Regular audits and status reports are necessary to ensure that the data warehouse is performing as expected. This includes monitoring system performance, tracking who is accessing the data, and ensuring that all processes are running smoothly. Regular reports also help administrators identify potential bottlenecks or areas for improvement. Replicating, subsetting, and distributing data. In many organizations, it is necessary to replicate data to other systems, create subsets of data for specific departments, or distribute data across different geographical locations. Managing these processes ensures that the data remains synchronized and available for use in various business applications. Next is backup and recovery, in which, like any critical system, data warehouses need to have backup and recovery procedures in place. Regular backups are necessary to safeguard against data loss, and recovery processes ensure that the warehouse can be restored quickly in the event of system failure or data corruption. Data warehouse storage management. Finally, managing the physical storage of the data warehouse is an ongoing task. As data grows, so do storage needs. Data warehouse administrators need to ensure that storage resources are efficiently utilized, employing techniques such as compression and partitioning to optimize storage and performance. Let's conclude today's lecture by discussing data administration and control. It helps us manage the entire lifecycle of data warehouse implementations. It is like a toolkit that lets us create, configure, run, and monitor data warehouse applications efficiently, even in complex environments where high performance and parallel processing are needed. Let's see some of the key features. First, we will start with simplifies installation and setup, which includes quick setup. It reduces the time it takes to install, configure, and get started. Create physical data models. We can design the structure of our data warehouse directly in DAC. Customize settings. Set the language, currency, and other configurations according to our needs. Design subject areas. Organize your data into specific subject areas and build execution plans around them. Next is manages metadata and relationships, which includes custom ETL execution plans. It lets us generate tailored execution plans for moving data. Capture changes, which means it can track updates to transactional databases like Siebel and even capture deleted records, so no data gets left behind. Index management, which helps to manage database indexes, ensuring faster query performance. Dry runs and testing. Before we run any data load, you can perform test runs to catch any issues early. Monitoring and reporting, which includes spot bottlenecks. That means DAC offers reporting tools that help identify where slowdowns are happening in the data process. Error alerts, which means if something goes wrong, it can send email alerts so we are on top of things. Detailed analysis, that provides structured ETL analysis and reporting to dive deep into performance and execution. Finally is performance optimization, which includes automate optimization rules, that helps automate the rules for optimizing both full and incremental data loads. Concurrency control, in which we can set how many ETL sessions should run simultaneously. Load balancing, that spread the workload across multiple servers to ensure smooth operation. Failure recovery, in which if a process fails, DAC allows us to restart from the point of failure, reducing downtime. Let's understand DAC repository objects in simple terms. When working with data administration and control, all the objects in the DAC repository are linked to something called a source system container. This container holds information about the source system we are working with. Let's learn the key parts of the DAC repository and what they mean for a data warehouse application. We will start with what are DAC repository objects. It stores the essential components of our data warehouse in a structured way, creating a framework that helps us manage different parts of the application. Here is a look at the main objects that make up a data warehouse application. First is subject area. Think of a subject area as a group of related tables that focus on a specific topic or business area, like sales or customer data. It also includes tasks that load data into those tables. We can assign subject areas to execution plans, which control when and how data is loaded, either fully or incrementally. Basically, it helps organize the tasks needed to load data into specific tables. Tables comes next. Tables in DAC are just like the ones in a database. They can be either transactional, storing day-to-day data, or data warehouse tables, which is used for analytics. Different types of tables include fact tables that store transactional data like sales numbers. Dimension tables that store details about dimensions like customer information. Hierarchy tables which help organize data hierarchically, example, regions and subregions. Aggregate tables that store summarized data for faster reporting. Tables can also be flat files that are either sources, where data comes from, or targets, where data is loaded. Task. A task is a small piece of work that loads one or more tables in our data warehouse. Task groups. Sometimes, we might need certain tasks to run in a specific order. In that case, we can create a task group, which is just a collection of tasks that need to be executed in a certain sequence. Execution plan. It outlines how and when data will be transformed and loaded into the data warehouse. The plan is based on our business requirements for updating the data warehouse, whether on a daily, weekly, or other schedule. Schedule. The schedule tells the system when and how often an execution plan should run. We can set up multiple schedules to define different frequencies for running the execution plan, whether it is daily, weekly, or at another interval. Let's see in detail the DAC process life cycle. The tool used by different user groups to manage the entire process of designing, running, monitoring, and troubleshooting data warehouse execution plans. These steps together form the DAC process life cycle. Here is a breakdown of each phase and the actions involved. First is setup phase. This is where we configure all the necessary settings to get started. Set up database connections which connect the DAC to our databases so it can access and manage data. Configure ETL processes which set up the ETL tools like Informatica that will move the data from source to destination. Set up email recipients which specify who should receive email alerts in case something goes wrong or once tasks are completed. Next is design phase. In this phase, we can define the structure and flow of our data warehouse processes. Define application objects that design the key components, like tables and tasks, that make up our data warehouse application. Create execution plans that plan how and when data will be moved and transformed in our system by designing execution plans. Execute phase comes next. This phase is where we can run and manage the execution of data warehouse processes. Define scheduling parameters which set up schedules to run execution plans at specific times, example, daily, weekly. Access runtime controls to have the ability to stop, restart, or adjust currently running tasks or schedules if needed. Finally, monitor phase. This is where we keep an eye on how everything is running. Monitor runtime execution to watch the progress of data warehouse tasks and make sure everything is running smoothly. Monitor users and jobs to track who is using the DAC, keep an eye on the DAC repository, and manage any background jobs related to application maintenance. Imagine a data warehouse as a giant library filled with lots of important information. The information delivery system is like a librarian who knows exactly where everything is and can deliver books, or in this case, data, to you whenever you need them. In summary, this lecture covered the following topics such as application in data warehousing, data warehouse architecture, and so on. In our next video we will see in some more details about architecture, data mining, and many more. Stay tuned for the next lecture, where we will continue our journey through data mining courses. If you want any other topic to cover, please let us know. If you have any queries related to this lecture, you can ask in the comment box. We will try to clear all your doubts. We hope that you have found this course informative. Please hit the like button and subscribe to our channel for more information on